Hello, everyone. Welcome to Secrets Beneath the Waves, the marine biofilms. So, who lives on the surfaces? Under the sea? Yeah, it's not a SpongeBob. They're marine biofilms. The marine biofilms are not studied as much as biofilms involved in our human health or with human diseases. All of our knowledge comes from biofilms on artificial surfaces, and they can range from bottles to oil platforms to sunken ships. And speaking of ships, did you know that historic shipwrecks have been known to provide surfaces for marine biofilms to attach? Now you know. The most important advantage of marine bacteria and biofilms is that they get access to resources such as carbon, energy sources, micronutrients, etc. Biofilms are also good for protection of the individual cells in harsh environments, such as UV exposure, change in temperature, and change in salinity, and others. There are so many benefits of the cells being clustered together. Some of them are the defense against predators and the better access they get to nutrients, because enzymes are required for metabolizing substrates, but these enzymes can also be used to feed neighboring cells. These biofilms produce extracellular polymeric substances, or EPS, and the EPS can act as a roof for individual cells. They can absorb and transport solids and microorganisms within the biofilm, and to protect them against predators, the cells in the biofilm can produce chemicals that are antiprotozoal compounds. They entrap toxic compounds and nutrients, and there's also quorum sensing happening. And there's not a lot of knowledge about quorum sensing in marine biofilms. But what we do know is that it helps coordinate these subpopulations, like regulating the genes within the biofilm. It can also explain why some biofilms behave almost as a single organism. Biofilms are known as agents for biofouling and corrosion, which we'll get to talk about shortly. 2.5 trillion US dollars is the global cost of corrosion. And just so we can understand it better, what can you buy with 1 trillion US dollars, you might ask? Well, you can buy all the major league sports. You can buy the NFL, NBA, NHL, NASCAR, all these teams combined, and you would still have over 3/4 left of the $1 trillion. You can buy Apple. You can buy the most expensive cars in the world. And you can even put people through college. If one person uses $30,000 a year, you can pay for the 4 years of 8.3 million people. And you still have left over to party with them. Now, you might be wondering, what is biofouling? So we'll talk about microbiologically influenced corrosion. And that is an electrochemical degradation process, and it is initiated, maintained, or enhanced by microorganisms and their metabolisms. On the other hand, biofouling is the accumulation of the microorganisms on submerged surfaces, and this can destroy the substrate. MIC, microbiologically influenced corrosion, and biofouling account for at least 20% of this cost of the $2.5 trillion. Biofilms are also harder to treat with antibiotics, and this might be because species may demonstrate or may show unique tolerance features. So all of this to say, some biofilms are becoming a marine environmental problem, yet we poorly understand their mechanisms. One of the challenges we must overcome to study this problem is to be able to duplicate the biofilm conditions and the limitations in techniques. Of course, marine biofilms also hold great biotechnological potential, including serve as sources of bioactive compounds such as antibiotics, cleaners of organic pollutants, etc. Not all biofilms are harmful. Some protect animals, but some cost trillions of dollars. But we need more studies to fairly understand the potential of marine biofilms. And these are my references. Thank you for watching.